Hello, fellow people of Mr. Lin's class. We're going to be doing stoichiometry. Welcome to Stoichiometry with Renell. So we're going to be looking at that one question Mr. Lin put up on the board today, and that was 10 grams of potassium nitride mixed with 10 grams of magnesium. And he wants us to find the ionic compound and the mass of it in grams, and the limiting reactant. What you're going to do first is build your chemical equation. So we know potassium nitride will be potassium and nitrogen. We know that nitrogen has a charge of 3 minus, or minus 3, and that potassium has a charge of 1, so plus 1. And so basically the charge of this number is the amount you need of that number. So potassium nitride would just be K3N. So we have K3N, and we're going to be mixing it with magnesium, or reacting with magnesium. So we'll just be using the element magnesium. So we know that K3N is an ionic compound because it consists of a metal, potassium, and nonmetal. So since magnesium is also a metal, those two are able to switch. This is known as a single replacement reaction. So we know that the K3N and the magnesium are going to be switching. So we have a good outline of what our chemical equation will be. So we have K3N plus magnesium is equal to magnesium 3N2. I found this because magnesium has a charge of plus 2 and nitrogen has a charge of minus 3. So if you just switch the numbers, you get Mg3N2. And then you'd have potassium on the side. Keep in mind that when you have an element out, you wouldn't keep the subscript that's with it. So for the K, you wouldn't have it as K3. That's bad. So if an element is taken out of a compound, so say H2O, if an element is taken out, only 3 elements can have a subscript. And those elements are hydrogen, oxygen, nitrogen, and the halogens. All of these will end up with a 2 by them. And so since potassium isn't one of these, it would not have a subscript. So just keep that in mind. Okay. So once we have that, we have our equation. K3N plus magnesium is equal to Mg3N2 plus K. So next thing we have to do is balance it. So we know that we're going to need at least 2 nitrogens because this compound over here has 2. So we would double this compound, making this have a total of 2 nitrogens and 6 potassiums, because 2 times 3 is 6. And so since there's 6 potassiums and only 1 potassium on this side, we have to make this 6. So we just make that 6. So there's another problem. The magnesiums don't match up. There's only 1 here and 3 there. So we would just put a 3 there as an easy fix. So next, we have our balance equation. So we have 2 moles of potassium nitrate and 3 moles of magnesium. We have 1 mole of magnesium nitrate and 6 moles of potassium. So if you're wondering what a mole is, it's basically the number of compounds or elements that is needed in an equation. So there you go. Okay, so now getting into the actual stoichiometry of this. Wait, actually, first we need the ionic compound that we need to find first. So we know that this would be our ionic compound because it consists of a metal, magnesium, and a nonmetal, nitrogen. So this equals an ionic compound, which is what we need to find. So basically, we need to find the mass of magnesium nitrate given these 10 grams of each, potassium nitrate and magnesium. So you would have your 10 grams of K3N and your 10 grams of magnesium. So keep in mind, when you're given 2 different starting reactants and the amount of them, you're gonna want to have 2 separate what's it called, stoichiometry lines, I guess. 2 different division lines. So first, let's just focus on this first one. So it'd be 10 grams of K3N, right? Just draw out your line just because. So the next step would be to find how many grams are in 1 mole of this compound. So you would do that. You'd find the atomic mass of potassium, which would be 39.098. And since it's K3, you would multiply it by that 3, and then you'd get a number, and then you'd have nitrogen, and then you would add nitrogen to that, the atomic mass of nitrogen to that. So after doing the calculations, you'll find that 1 mole of potassium nitrate is equal to 131.301 grams of potassium nitrate. So because I put the mole on top and the grams on bottom, I'm able to cancel this out, because you can only cancel out a unit if it's on the top and bottom. So next, we have to find the amount of moles we need here to the amount of moles we need of magnesium nitrate. So in this equation, we know that we have only 1 mole of magnesium nitrate, but we have 2 moles of potassium nitrate. So we know that we're going to have 1 mole of magnesium nitrate for every 2 moles of potassium nitrate. So basically, from here, we know that these would cancel out, and I strategically placed it so that the moles of potassium nitrate would cancel out also. And so now we have magnesium nitrate, and we need to find the molar mass of it, basically finding the grams. So after doing the calculations, you would find that 1 mole of magnesium nitrate would equal 100.929 grams of magnesium nitrate. Okay, so because we put the moles on bottom, we're able to cancel out this unit, and now we're just left with grams of magnesium nitride, which is basically what we're trying to find. So we would take everything on the top, multiply it. So it would be 10 times 109.29 divided by 131.301 times 2. Keep in mind, when you're calculating this on your calculator, always have this in the parentheses. So after you do that, you would find that it's roughly 3.84, if I remember correctly. 3.84 grams per mole. Oh wait. Yeah, 3.8 grams per mole of magnesium nitride. So after you do that with potassium nitride, we're done with this. But now we have magnesium to work with. So we basically do the same thing. Let's just go through it quickly. 10 grams of magnesium. 1 mole of the magnesium is equal to 24.305. And then how many moles of magnesium do we need to find what we're trying to find? So it would be 3 moles of magnesium for 1 mole of that. Also keep in mind putting the moles of magnesium on the bottom so that it can cancel out. Magnesium, and then 1 mole of Mg3N2. And then you would cancel those out. And then you have to find the molar mass of what you're trying to find. So you'd have 1 mole of Mg3N2 would be equal to 100.929. Just use the one up here. And then Mg3N2. So those would cancel out. And then now you're basically left with sort of the same problem. 10 times 100.929 over 24.305 times 3. Make sure you keep that in parentheses. And then if you do that, you'll get roughly 13.84 grams per mole of magnesium nitride. So this would help us, having these two values, 3.84 and 13.84, if I remember correctly, you would be able to find the limiting reactant. The limiting reactant is the answer that has the lower amount produced. So if you look at the values, this is the lower amount. So if you look back at our starting, potassium nitride is going to be our limiting reactant. So limiting reactant is potassium nitride. And now, since we need to find the mass of the ionic compound, it's only possible to make 3.84 since this is our limiting reactant. So our answer would just be straight up 3.84 grams of magnesium nitride.